4.1. We are going to be solving radical equations. And this chapter really isn't about radicals, but they don't fit anywhere, and they're not, I mean, it's only 2 sections, so we're going to throw it into this chapter just for fun. So if I had the square root of x equals 6, what number satisfies that? 36. So if I made it a little bit more complicated, x minus 3 equals, let's say, 7. You might be able to figure that out in your head, but let's solve this algebraically. How do you undo a square root? You square it. Why does that work? You're multiplying it by itself. Good. So the square root is really the 1/2 power. And if I take an exponent and raise it to an exponent, I multiply those two things together. And then I get x to the 2 over 2, which is just 1. That's why it works. Okay. So down here, we square both sides. X minus 3 equals 49. Then we add 3, and we get x equals 52. Make sense? Let's make it a little bit harder. How do I solve this? Square both sides. 2x minus 4 equals 4. Why don't I need a plus or minus? That happens when you're going the other direction. If we have x squared equals 9, and then we square root it, then we need a plus or minus. So add 4. 2x equals 8. Divide by 4, or divide by 2. X equals 4. Okay, but every once in a while, something funny happens. So, square both sides. No, we won't. Add 6. 42, divide by 3. That'd be 12, 13, 14. I like what you're thinking, you're just not quite right. Why is he worried about imaginary numbers? There's a negative. Okay? When do imaginary numbers happen? When you square root a negative. Not when you square a negative. But what do you think about this answer? It is. If we plug 14 in, so we stick it in there, I get the square root of 42 minus 6, which is the square root of 36. Is that equal to negative 6? No. So I just found a solution to a problem that doesn't actually work. So remember when we did rational functions and we found holes in vertical asymptotes? And sometimes the answer to the equation was a hole or a vertical asymptote. What did we do with those answers? We just chucked them. They're called extraneous solutions. I don't know what extraneous means. The only time I ever hear this word is in math. So, what about this? Is it going to work? Yes. Now, textbooks will tell you when you get the answer, plug it back in to see if it's an extraneous solution or not. We're smarter than that. Yeah, we can look at a problem beforehand most of the time and say, oh, wait a minute, that doesn't have any answers. Because if I plug 4 in here, 2 times 4 is 8, 8 minus 4 is 4, the square root of 4 is 2. But how did I know it was going to work before I even plugged it in? This is a positive number. Can a square root equal a positive number? Yes. But over here, can a square root equal a negative number? No. What is the square root of a positive number? A positive number. What's the square root of 0? 0. What's the square root of a negative number? An imaginary number. But it's still a positive imaginary number, right? So there is no mathematical way to take the square root of a number and get a negative. So you guys have learned about imaginary numbers. They're numbers that didn't exist on the number line. Well, they still exist, but there is no number that satisfies this equation. It simply has no solution at all. Okay, and sometimes you have to be a little bit careful because, well, I'll just show you. So let's say I had should I solve this? Yes. Why? Can you take the square root of a number and subtract 6 from it and get a negative 3? Yeah. Because when you add that 6 over, the right side becomes positive. Okay. What if I changed it to that? No. That does not have a solution. Okay. What about this? No. So, when you solve these, take a look. Does the square root equal a positive number? If it does, solve it. Does the square root equal a negative number? If it does, the answer is no solution. Okay? But, what about this? Yeah. This works if the answer we get is greater than 0. Right? Greater than or equal to 0. Right? The only problem we're going to run into is if x is negative. Right? Because the right side cannot be negative. So how do we solve this? And this might not work. I might have to change it up a little bit here in a second. So let's square this and square this. I already know it's not going to work. We're going to make that a 2. Wait, nope, that won't work. Anyway, I'll change it as I need. But I'm going to square both sides. So the left side is x minus 4, and the right side is x squared. Okay, let's make this a 6. That is the weirdest 6 I've ever drawn. Okay, now what? I have a quadratic. Move everything to the right. Oh. This is why you don't make these problems on your own. Okay? Everybody understand what I've done? Squared both sides, get rid of the square root. I see x squared, which means quadratic, 2 solutions. So I move everything to the right. And now that I've changed it 3 times, it factors. The factors are x minus 3 and x plus 2. So my answers are 3 and negative 2. But going back to the original problem, am I okay putting a 3 right there? Yes. That works. Am I okay putting a negative 2 right there? No. Oh, that was a plus, huh? Does that make sense? Okay. What if it said this? Oh, jeez. Can I plug a 3 in there? No. Can I plug a negative 2 in there? No. So this would be no solution. Okay. What if it said they both work? Does that make sense? So when you solve these, if this number is positive, then the answers exist. If this number is negative, then the answers do not exist. If that number is a variable, then the same rules apply. Positives are yes, negatives are no. What about zeros? So if one of the answers was 0, is that okay? Can you get 0 by taking a square root? Yes. And then what if it said that? Then you just plug the x in to see if it yields a positive number. So would any of those numbers work with an x plus 1? 3 and 0 would both work. What if it was x minus 1? Just the 3. The other two don't work. Okay, let's take a look at your assignment. So most of these are going to be really easy. Square root of what number is 10? 100. Piece of cake. Square root of what number plus 8 is 9? So you square both sides, and you get w plus 8 equals 81. Subtract 8. W equals 73. And how did I know this does have a solution? That number is positive. If that number is negative, then the answer is no solution, and I'm done. Okay. Does this have a solution? Yes. Why? Is it because the 5 is positive? No. Because when I subtract 1, I get a 4, and the 4 is positive, or 0. 0 would work too. And then you square both sides and solve. Okay, let's get to some of the more difficult ones. How would you do this? Square both sides. Do I need to worry about extraneous solutions? Can a positive square root equal a positive square root? Yes. So if you have a square root equals a square root, there is no way to ruin the answer. So people who are not lazy would square both sides. Bring this over. Would square both sides, but people who are lazy like me just drop the square roots. If you have the square root of something is equal to the square root of a different something, then those two somethings have to be the same. So you could just solve like this. 12 equals 2x, so x is 6. Do I need to plug it back in? Not as long as you did your algebra correctly. Yes? Because I moved the negative 3x to the other side. I just solved it. Okay. Same thing there. Okay. Square both sides. On the left, I get 18 minus u. What do I get on the right? U squared plus 4u. How did I know it was 4u? It's this times this plus this times this. So it's really 2 copies of 2 times u. And then plus 4. Now what should I do? So add the u and subtract the 18. U squared plus 5u minus 14. Are there 2 numbers that multiply to be negative 14 and add to be 5? Positive 7 and negative 2. So u is negative 7 and 2. Should I throw out the negative 7 because it's negative? No. I need to plug it in and see if it equals a negative on that right side. So if I put a negative 7 in there, do I still get a negative? Yes. So that one gets thrown away. Am I okay plugging a 2 in there? Yes. Okay. Those are your 6 types of problems. Any questions? Okay, get to work.